Okay, so this is chapter 6, and it's called Using Decision Structures. And basically, we're talking about using an if-then statement. So you already done it many times, and should be familiar, and you've used it, you know how to use it. So this is almost a review, but we're just going to look at a few details to try and understand a little more carefully what we've been doing. Now there's a second similar type of structure called select case, and we'll also look at that. Okay, so we've talked in previous videos about what we mean by event-driven programming. Basically, an event-driven program, as opposed to maybe older style DOS programs, the program responds to what the user does, and that's exactly what we've been doing all along. So he says the program puts the user in charge and waited patiently for a response and then processed the input in a predictable way. In programming circles, this methodology is known as event-driven programming. You build a program by creating a group of intelligent objects. These are so-called intelligent objects, each of these, that know how to respond when the user interacts with them. And then the program processes the input by using event procedures, and those are what? Those are the little sub-procedures that we've written many times. So here's they say a following diagram shows how an event program works in Visual Basic. So we know about this because we've done it many times. So, but let's look at the language they're using. Receive input by the using object. So this is the using object. Maybe this whole thing is the using object. It's the group box here, and we have a radio button there, and that's also part of the using object. And then process the input by using event procedure. So the event procedure would be in here, and we'd click order, or maybe actually even in here, and then return control to the user. And now he reminds us also that input may come from the user, but it may also come from the computer system itself. For example, he says your program might be notified when a piece of electronic mail arrives. So that's not you, but maybe the computer sends a message to your program saying that mail has arrived, or when a specific period of time has elapsed on the system clock. The computer, not the user, triggers these events. Regardless of how an event is triggered, Visual Basic reacts by calling the event procedure. So when a button is clicked, then the event procedure associated with that button will handle the button click. So Visual Basic reacts by calling the event procedure associated with the object that recognized the event. So far you've dealt primarily with the click, check changed, and selected index changed events. So in other words, a button click, or if the checkbox was clicked, that's the check changed event, or selected index change, that's like in a list box, if you select one of the choices in a list box. However, Visual Basic objects also can respond to several other types of events. Then he says the event-driven nature of Visual Basic means that most of our computing is accomplished by event procedures, and that's basically where all of our computing has been done. We've done it in the event procedures, like in the button click procedure. Okay, so let's think about the different possible events associated with our different objects. For example, we know that a button can respond to a button click, and we know that a checkbox can respond to whether the box is checked or not. So we're talking about events supported by Visual Basic objects. And each object in Visual Basic, whether it's a button or a checkbox or a list box or whatever, has a predefined set of events to which it can respond. These events are listed when you select an object name in the class name list box at the top of the code editor, and then click the method name arrow. So let's check that out. So here I have a form, and if I double click on it, I see some code there, but they're talking about up here. So if you look up here, you can see the different objects or controls that are in this form. So button 1, there's a label, there's another label, there's maths text box, we haven't actually dealt with that, and this one. Let's just take a look at it again. You can see there's a button here, there's a text box, there's a text box. So the objects are, there's also a label in there. These happen to be what are called masked text box, which we'll learn about, but basically it's just a kind of text box. So these are the objects, and then if you want to know, for example with button, what are the different events that it can respond to? Now we already know one of them, and that's the button click event. Okay, but what are the other ones that it might be able to respond to? You select this one, and you can see that one of them is the button click event over here. But there are a whole lot of other ones here. There's a client size changed, context menu changed, context menu strip changed, control added, control removed. So there's all these different methods or event procedures that are associated with button 1. Again, each object in Visual Basic has a predefined set of events to which it can respond. These events are listed when you select an object name in the class list box that's here at the top of the code editor, and then click the method name arrow. So here, click these. Events are visually identified in Visual Studio by a lightning bolt icon. So these lightning bolt icons, or here. Well, okay. You can write an event procedure for any of these events, and if that event occurs in the program, Visual Basic will execute the event procedure that's associated with it, and so it will execute the code that you just wrote. For example, a list box here, supports more than 60 events. So here's part of the events, part of the 60 events, including click, double click, drag drop, drag over, got focus, key down, key press, key up, lost focus, mouse down, mouse move, mouse up, mouse hover, text changed, and validated. So if the user double clicks on a list box item, you could have it respond in a different way by writing an event for double click. You might allow for dragging and dropping elements in the list box. You might allow for just the mouse down event. So it's not clicking it, but just when they press the mouse button down, not bring it back up yet, just press it down, you might have a certain event. Okay. Also, just mouse hover. That means if you just hover over with the mouse, you could have something happen if you want. Text change. So as soon as the text is changed, there could be an event. So it has all of these different possible events associated with this list box. So you might experiment with this and try to write some events and then see what happens. See, when you do something with the mouse, like hover, just hover over the list box, you can have something happen. Like you could have a message box appear, or you could have an input box appear, or you could have something else on the screen change color, or change text, or whatever you wanted to do. So this is more of that same list there. So I suggest that you try and experiment with that. Try with the hover here. this one. It's called mouse hover. You could write an event so that when the user hovers over the object, something happens. And you can define what you want to happen. Okay, now let's go on to the topic of using conditional expressions. One of the most useful tools for processing information in an event procedure is a conditional expression. A conditional expression, remember, just means, well, conditional expression is something like that. Okay, sorry. A conditional expression is part of a complete program statement that asks a true or false question about a property, or a variable, or another piece of data in the program code. For example, the conditional expression, price is less than 100. Okay, so this is called a conditional expression. Then we might say, if this conditional expression is true, then do something. So price is either, for a particular price, it's either going to be less than 100 or it's not going to be. So this is either going to be a true statement or a false statement. So they say this evaluates to true if the price variable, this variable, contains a value that is less than 100. So for example, if price was 50, then this would be true. And we'd say this evaluates to true. So then if I wrote a statement like, if price is less than 100, then show a message box. So then we would show a message box. And this part here is called a conditional expression. And a conditional expression is going to be either true or false in this case, and depending on, well, here, depending on what price is equal to. They say this evaluates to true if the price variable contains a value that's less than 100, and it evaluates to false if the price contains a value that is greater or equal to 100, right? If the price is equal to 100 here, then this will be false, right? Because 100 is not less than 100. So this is one of the so-called comparison operators. This less than sign is called a comparison operator. Okay? And then we have other comparison operators as well. So we have less than is one comparison operator, but we also have greater than, which is another comparison operator. We also have less than or equal to, which is written this way. And we also have greater than or equal to, which is written this way. And we also have this one, which is how you write not equal to. Okay, not equal to. And this is equal to. So remember that a conditional expression is going to either be true or false. Okay, so this one. What does this conditional statement say? It says 10, this is read, is not equal to 20, which is true, right? So it evaluates to true. Score is less than 20. This will evaluate to true if score is less than 20, and if score is equal to 20 or greater than 20, it will result in false. Score equals label1.text. So if label1.text, if label 1 has a string value of score, if label1.text has the same value as score, then this will evaluate to true. Now score here is a variable. So if this equals the value of this variable, then this will result in true. Here, if textbox1.text equals Bill means if the text property of textbox1 is Bill, then this will evaluate to true and otherwise false. And now we come to the if-then decision structure, and we put a condition in here. So if the condition is true, then, and then we want to do something. And this is called an if-then decision structure. It's obviously called a decision structure because you can make a decision here. So anyway, we have the conditional expression inside as part of the if-then statement. Okay, or the decision structure. So they say, when a conditional expression is used in a special block of statements called a decision structure, It controls whether other statements, this statement for example, in your program is executed or not, and in what order they're executed. You can use an if-then decision structure to evaluate a condition in the program and take a course of action based on the result. Okay, so we've done this many times, but it's good to go through this to learn the language here. What I mean is to learn that this is called a decision structure, that what's here is called a conditional expression, and that these are other statements. In its simplest form, an if-then decision structure is written on a single line, like this. So we can write it like this on a single line, where condition is a conditional expression, and statement is a Visual Basic program statement. For example, if score is greater than, what's this called again? This is called the greater than or equal to operator. Comparison operator, the greater than or equal to comparison operator. What's this called? This is actually, in this case, this is an assignment operator. Okay, so it says if score is greater than or equal to 20, then label1.text equals you win. Okay, so we're going to display in label 1 its text you win if score is greater than or equal to 20. In other words, if this conditional statement is true. And they call this an if-then decision structure that uses the conditional expression score is greater than or equal to 20. Now, if score is less than 20, then this won't be true. Then this won't get executed, we say. Okay, this statement won't get executed. It'll just skip this. They also say a conditional expression never results in a maybe. It's always either true or false. Okay, let's look at this example, or let's think about taxes, when you pay taxes on your income. So how much you earn per year and how much you have to pay in tax. So let's read this and see what it says. So adjusted income, that's your income, basically your income for the year. So let's say your adjusted income is this number, which is 50,000, right? So now here's we see a bunch of if-then statements. Actually, they're slightly different, but let's look at it. What does it say? If your adjusted income is less than or equal to this number, which is 7,825, then supposedly you're in the 10% tax bracket. That means the tax due will be equal to, and notice that a tax due was one of the variables that was defined at the beginning of the program as a double. And adjusted income was also a double and defined at the beginning. Okay, anyway, then your tax due will equal your adjusted income, which is 50,000, times 0.1. In other words, 10% of your adjusted income. So you'll have to pay 10% tax. Now, what they're saying is, if your income is low, you only have to pay 10%. But if your income gets higher, so if it's less than 31,850, then you're in the so-called 15% tax bracket, which means you have to pay 15% of your total income in tax. In other words, your tax due is, let's see, how does this work? It's a little different. What does it do? It takes your adjusted income, which was what? 50,000, and subtracts 7,825, and then multiplies that by 15. So what is it? If you subtract 7,825, say your income was $30,000. Okay, so which is less than 31,850. So suppose your income was 30,000. Then your 30,000 minus this. Let's just make it easy. Say this is equal to 8,000, just to make this simple. Okay, so subtract 30,000 minus 8,000 would give you 22,000. So you take 22,000 times this number, times 15%. You'd have to pay that in tax. 15% of 22,000. But remember I said that your adjusted was 30,000. So there's still 8,000 that so far you haven't paid any tax on. I changed this number to 8,000 just to make it simple. So what about that? Then you also pay 10% on that first 8,000, or actually on that first 7,825. So on the first 7,825 of money that you earn, you pay 10%, and then on the rest, up until 31,850, you pay 15%, and that's what this does. Okay, so we're paying 10% on the first this much that we earn, and then if we earn more than that but less than this amount, the rest for the rest of that we pay 15% of that. Okay, and then it goes on. If your income is less than this, then you're going to do the same thing that you did up here. You're going to take the adjusted minus the 31, and that's going to be taxed at 25%, and the stuff before the 31 is going to be taxed at this rate and this rate, and anyway. Okay, so we don't have to go through all the details. Okay, but the point here is that we have kind of like an if-then statement. But it does a little bit more than just a single if-then statement, because what does it say? If it was just a single if-then statement, it would say, if this, then this, and then stop there. But it doesn't stop there. It has another part. It says, else if, so it gives you basically another condition you can consider, another conditional statement you can consider, else if, and now we have a new conditional statement here, different than this one, and in that case we do something else. And if it doesn't satisfy this one, if this conditional is not true, and this conditional is not true, then we'll check a different conditional, this one. And if this conditional is true, then we do this, and if not, we'll check a different one. If this conditional is true, we'll do something, and if not, we'll check this one because it says else if. So we'll check if this is true, and then we'll do something. And finally, there's a final clause, which is just an else clause. Else, so it's not else if, it's just, we don't say else if, so we're not asking if anything else is true. We're just saying do this if none of these are true. So else, tax due, equals some other formula. And then we have to have the end if at the end. Okay? So this is testing several conditions in an if-then decision structure. So we still call that whole thing an if-then decision structure, even though it has the else-if statement as well. So again, here it is. If condition 1, then do a bunch of stuff. Statements executed if condition 1 is true. And then we have another choice that we want to put in, another condition that we want to evaluate. Else if condition 2 is true, then do something else. And we can keep going more of these statements. And then finally we can have an else at the end, which says if none of the others are true, do this. Now we don't have to have the else at the end. We could just leave it without that. But then if none of the other statements were true, we wouldn't do anything. So it depends if you want to say what to do in case none of the other statements are true or not, if you want to put an else statement in there. So let's read this. In this structure, condition 1 is evaluated first. If this conditional expression is true, the block of statements below is executed one statement at a time. You can include one or more program statements. So you don't have to have just one statement here. You could have many things happening if this is true. You could have maybe you could have a text box change its color, you could have a message box occur, you could have lots of different things all happen if condition 1 is true. So you can have many statements here. Okay? If the second condition is true, the second block of statements, so this block of statements, there would be a block of statements here, you could have more than one, is executed. You can add additional else if conditions and statements if you have more conditions to evaluate. If none of the conditional expressions is true, then the statement below the else keyword are executed. So if none of the conditions above are true, and you do include an else statement, then all of this stuff will be executed. And finally, the whole structure is closed by the and if keywords. Okay, and again, this is an example of that. Now, one thing they mention is that what happens if I wrote this in reverse order? So instead of saying if it's less than or equal to 7825, then do this, if I wrote this part, if it's there, then do this. Okay, this is, suppose I would put this one first, and then this one next here, and then this, and then this one next after that, and finally this, and then this one next, and then finally this one at the end, this one at the end. Okay, what would that do? So then the first thing we would evaluate is what? Here, say this one. The first thing we would evaluate, say, was this one. So we'd say if adjusted income is less than this, then your tax due would be this plus some other number, right? But that would be totally wrong, because suppose your adjusted income was $5,000, so it was less than this number, right? So you're only supposed to be taxed at 10%, right? But if you reverse the order of these, the first thing that would be checked is your adjusted income less than this number? Of course it is. 5,000 is certainly less than this number. So then it would say that your tax due is this plus some other number. This is what, 39,000. So that would say that you earned $5,000 and your tax due is $39,000. So that's ridiculous, and certainly is not 10%. So the order that you write this logic in is very important. So he says, the order of conditional expressions in your if, then, and else if statements is critical. What happens if you reverse the order of the conditional expressions in the tax computation example and list the rates in the structure from highest to lowest? Taxpayers in the 10%, 15%, 25%, and 28% and 33% tax brackets are all placed in the 35% tax bracket because they all have income less than that number, this number, right? In other words, Visual Basic stops at the first conditional expression that is true. So if this is true, it doesn't check these or these or these or these or these. Okay? Because all the conditional expressions in this example test the same variable. So here we're testing if adjusted income is less than this, or adjusted income is less than this, or adjusted income is less than this. Now we don't have to, you could write an if-then decision structure with several clauses like this, but they could be testing different variables each time. So this could be if adjusted income is less than or equal to this, else if something else is something else, like if the color of the ball is red, then show a message box or whatever. Anyway, these variables don't have to be the same, but in this case they were. So because all the conditional expressions in this example test the same variable, they need to be listed in ascending order to get the taxpayers to fall out into the right places. Moral: when you use more than one conditional expression, consider the order carefully. Okay? Now notice also that if you switch the order here, of course that's not what you really want to happen, but the compiler would never know that, right? So the compiler wouldn't tell you you made a mistake. And when you tried to compile the program, in other words, when you click the green arrow in Visual Studio, it would compile fine. It wouldn't know that you had written the problem was written logically incorrectly. It would work just fine in terms of compiling. And also, you wouldn't even get a runtime error. We talked a little bit earlier about runtime errors. You wouldn't even get a runtime error because there's no error that that the program knows is a mistake. I forget what our example was before when we got the when we tried to put I used a number use text in something that was supposed to be a number. So then that would be a runtime error, and you would get an error message. But here you would get 0 error messages, right? But the calculation would be completely wrong. So that's not a runtime error. That's not a compilation error. And those are probably the hardest kinds of errors to find, because Visual Studio doesn't help you to find them. Okay, and let's take a look at this. This useful decision structure tests the double precision variable adjusted income. So it's double precision because it was declared as a double. At the first income level and subsequent income levels until one of the conditional expressions evaluates to true, and then determines the taxpayer's income tax accordingly. With some simple modification, it could be used to compute the tax owed by any taxpayer in a progressive tax system. This type of tax scheme is called a progressive tax. It means that as your income increases, you pay a higher rate, and specifically here you pay a higher rate but just on the sort of residual amounts, right, like we saw. Anyway, in a progressive tax system such as the one in the United States, provided that the tax rates are complete and up to date, so provided that we include all of these, and maybe there's even further ones that you have to include, conditions, maybe it goes higher than this, and provided that these numbers, like this 33% and 28%, are up to date, that is, they're actual correct for the current time in terms of tax, and that the value in the adjusted income variable is correct, the program as written will give the correct tax owed for single U.S. taxpayers in 2007. If the tax rates change, it's a simple matter to update the conditional expressions with an additional decision structure to determine taxpayers' filing status. The program readily extends to include all U.S. taxpayers. Okay, so now I want you to do this one for homework. So, but before, let's read this. Tip: expressions can be evaluated as true or false. Expressions that can be evaluated as true or false are also known as Boolean expressions. So we saw a bunch of conditions or expressions that would be that can be evaluated as only true or false. Such expressions are called Boolean expressions. So here's a Boolean expression because it's either true or false. Again, here's another Boolean expression because it's either true or false. So whenever an expression can be evaluated to either true or false, it's called a Boolean expression. Boolean expression. And the true or false result can be assigned to a Boolean variable. So we've talked about Boolean data types, and those are variables that can either be true or false. And so if you have a Boolean expression, you can assign the value of it to a Boolean variable or a Boolean property. You can assign Boolean values to certain object properties or Boolean variables that have been created using the dim statement and the as Boolean keyword. So if you have a variable which was defined as Boolean, then you can take a Boolean expression which is going to be either true or false, and you can say let that equal the Boolean variable that you just created. Okay, so in this part of your homework, you're going to use something called a mass text box. Let's just quickly see what that is. You're going to create a form like this, maybe not with the bottom part, but with the top part. And this is called a masked text box. It's a text box, but let's see, what does it say here? It's called a masked text box. And that's because we'll only allow certain kinds of entries in here. So we put a kind of a mask over the text box to force the users only to be able to put in certain kinds of information. So like This is for what's called in the United States your Social Security number, which consists of 3 numbers and then a hyphen and then 2 numbers and then another hyphen and then 4 more numbers. So that's the only kind of thing that this will accept. If you try and put anything else in there, it won't let you. So it's called a masked text box, and that can be useful when you're programming if you want to insist that the user insert a certain form into the field. And there's some way to change, so there's a certain set of masks that you can use. Now, if you're programming something for Japan, you wouldn't need Social Security number. They don't have a Social Security, as far as I know, of this kind of form. So there might be special masks that apply that are useful if you're doing something for a Japanese user. There's some way to change the locale in here so that you could access different sorts of masks depending on your locale, but I don't know if you can do it in my version. This is the free version, 2008 free version. There's probably a way that you can do it in the paid version. These are the masks that I have in my version. So here you can see the Social Security number, which looks like might look like this. Okay, but there's also a telephone number, which this is a U.S. type of telephone number. So if you want to insist that somebody puts in a phone number like this, you could do that, and so on. There are different times and so on. So you're going to use this to create that form. So here are the instructions, and I'm not going to go through them. I'm going to let you stop the video at different points so you can read the instructions and build the form. So here's the first set of instructions up to instruction number 4. Here's instructions 5 through 6. So you can stop and read these. Here's instruction 7. Here's a little more of instruction 7 and instruction 8. And here 9 and 10 and 11. Of course, you don't want to save it here because this is not where your your folders are located. So you want to save it where you can deliver it as homework. 12, 13, and 14. 15, 16, and 17. Okay, so you should include that as part of your homework. Okay, let's go on to using logical operators in conditional expressions. So remember, we've talked about decision structures, which are if-then, and inside the if-then statements we have conditional expressions, like in here. And they're saying within a conditional expression you can actually have logical operators. Remember, logical operators are things like and, or, not, and XOR. So let's look at that. And this will allow you to have more than one condition in your conditional expression. For example, you might have as your conditional expression not just like price is less than 300, you might, or not just like vehicle equals bike. So you might have a variable called vehicle, and you say if vehicle equals bike, then do something. But here you can do two things. You can use two conditions. You can say, you could put if here, if vehicle equals bike and price is less than 300. So if both conditions are true, then do something. But not if one of them is true and the other is false, that's not good enough. It's if both are true. Here we have if vehicle equals car or if price is less than 500. That would mean if either one is true, then maybe do something. Okay, but it doesn't, you don't have to have both of them true. You can have one of them true or the other one true, or both of them true. If both of them are true, you still say, if vehicle equals car or price is less than 100, then do something. If it's true that vehicle is car and price is less than 500, you still will do that something. That's what this or means. Okay? Then you can also have not. If not price is less than 100, okay, then do something. Okay, if not price is less than 100, then do something. And then they have one more called XOR, and that means if this is true or this is true, then do something. But if they're both true, it's not, don't do it. Don't do that something. So it's a little different than this one. This one, if they're both true, you will do that something still. But if this one, in this case, if you use this XOR, then if this is true, but this one is not true, then you will do that something. If this one is false and this one is true, then you still will do that something. But if they're both true, then you won't do it. Okay, that's called XOR, or exclusive OR. So let's read it. And if both conditionals are true, conditional expressions are true, then the result is true. Or if either conditional expression is true, then the result is true. Not. If the conditional expression is false, then the result is true. If the conditional expression is true, then the result is false. And XOR, if one and only one of the conditional expressions is true, then the result is true. If both are true or both are false, then the result is false. So it's called the exclusive OR. So let's read this one more time. The following table lists some examples of logical operators at work. In the expressions, it is assumed that the vehicle string contains the value bike. So suppose vehicle does actually equal bike. And suppose that price equals 200. Then what about this statement? Vehicles equals bike and price is less than 300. Both of these are true, right? This is less than 300. Vehicle does equal bike. So they're both true. So this statement with the and in it would be true. On the other hand, what about this one? It says if vehicle equals car or price is less than 500. This one is true, but this one is false, but still the whole thing will be called true. Okay, now how about this one? Price is less than 100. No, that's not true, right? Price is 200, so that's false, but we put not in front of it, so you can read it as this is false, and then not false becomes true. Okay? And then finally, vehicle equals bike, that's true, or, sorry, exclusive or, price is less than 300, that's also true. This will be false. So be careful, that's the meaning of exclusive or. Okay? Okay, so actually for homework, you can do this whole thing. So not just the previous exercise, but you can include this part in it as well, and you can deliver these two together as one form. So in the following exercise, you'll modify the previous one that we just did, or that you just did, to prompt the user for a personal identification number, a PIN number, during the validation process. To do this, you will add a second text box to get the PIN from the user, and then you're going to modify the if-then clause in the decision structure so that it uses the AND operator to verify the PIN. So most of this is straightforward, but let's look at here, this statement here. If the text value equals this, and the mass text box 2 value equals this PIN number, so we're saying the user has to have this PIN number, and if that's true, then the message box will say, welcome to the system. Otherwise, it will say, I don't recognize this number. Okay, so that's the logic here. And notice that we are using AND. So what does that mean? It means that in order for us to do what it says after the then, in other words, in order for us to do this, what has to be true? and means that this one has to be true and this one has to be true. Don't forget this symbol here means continue on to the next line. So space, this underscore means continue on to the next line. So if, once again, so if this is true and if this is true, then we'll say welcome to the system. Otherwise we'll say this. Okay? So we have the and. Remember, and is true only if both pieces, both this one and the one on the right of it, are true. So here are the instructions for this part. So 1, 2, 3, 4, 5, 6, 7. And then after you finish that, eight, 9, 10, 11, 12, 13, 14, and that's it. Let me show that to you once more. 11, 12, 13, 14. That's it. They also say that you can further customize this program by using the password car property in the masked text box objects. And what that does is, when you type in something, when you're supposed to type in a password, sometimes there's a bunch of, everything is hidden, right? You can't, even as you're typing it, nobody else can really see what you've typed in. So it fills everything, it changes everything to an asterisk. So that's what this does. So you can try it. You specify the character by using the properties window. Using a password character gives additional secrecy to the user as they enter their protected password. Okay? Okay, now we're not going to do this part, but if you want to read it, you can. I'll just scroll through it slowly so that you can read it. And the next thing we're going to do is the select case decision, which is kind of an alternative to the if then else if structure that we just saw before. The if then else if structure. This is kind of an easier way to do that but it doesn't work in all if then else if cases, but in some it does. It's called the select case decision structure.